What precisely lies at the edge of the observable universe? Well, this has remained a mystery for hundreds of years, fueling interest and hypothesis amongst scientists and fanatics alike. However, the James Webb Space Telescope holds the key to unveiling this cosmic thriller with its powerful lenses peering deeper into space. It has lately made a groundbreaking assertion of what lies at the edge of the observable universe. When we speak about the edge of the universe, it is important to apprehend the concept of the observable universe. The observable universe consists of everything that we can see, measure, and examine from Earth or our space-based telescopes and exploratory probes at the existing time. It consists of stars, galaxies, and other celestial objects that are within our observational reach. So what's the distinction between the universe with a capital U and the observable universe? In simple terms, the observable universe is just a small fraction of the whole universe that we can observe and comprehend. While the total length and shape of the entire universe are unknown, there is an estimated diameter of the observable universe, which is around 93 billion light-years. Now, a light-year is a unit of distance that light travels in 1 year, which is about 5.88 trillion miles or 9.46 trillion kilometers. So, the diameter of the observable universe, 93 billion light-years, is an unimaginably tremendous expanse spanning approximately 5.68 times 10 to the power of 23 miles, a mind-boggling scale of our cosmic environment that's hard to even realize. But why is the universe so highly extensive? The answer lies in its origins. The Big Bang Theory tells us that about 13.8 billion years ago, the universe was born in a powerful explosion. This explosive event led to a rapid expansion, and since then, the universe has been expanding at an increasingly faster pace, driven by enigmatic forces like dark energy. As the universe expanded, particles of matter began clustering together due to the force of gravity, forming or inspiring structures such as stars, galaxies, and eventually even planets like our beloved Earth. Over infinite years, these cosmic systems grew larger and more complicated, leading to the great diversity of objects and phenomena that we observe throughout the universe today. Despite the vastness of the universe, it is predominantly empty. To put it in perspective, if we scaled down our entire solar system to the size of a quarter, the closest star would still be the distance of 2 football fields away, and that's just inside our Milky Way galaxy, which is one of billions in the observable universe. You might wonder, why can't we see the entire universe? There are 2 factors that explain this. The first reason is that light takes time to travel through space. When we observe remote objects in the universe, we're actually seeing them as they were in the past. The farther away an object is, the longer its light has taken to reach us. So, by observing remote galaxies, we are essentially peering back in time, unraveling the history of our cosmos. The second reason is the universe's expansion. Imagine dots on the surface of an inflating balloon. As the balloon expands, the dots move away from each other. The same principle applies to the universe, where galaxies are drifting apart as space itself stretches. This expansion causes the light from distant objects to become stretched too, moving towards longer wavelengths, which we perceive as redshift. Eventually, some objects will move beyond our observational reach as they recede. Considering these factors, it is not surprising that we have not seen the entire universe yet. Now, the idea of the edge of the universe is a mind-boggling topic that has fascinated scientists, philosophers, and thinkers for ages. We have all forms of theories about what lies beyond, but the truth remains elusive. But there are 3 theories that stand out. The first theory is that the universe goes on forever with no end in sight. This theory is based on the cosmological principle, which states that the universe is isotropic, meaning that it appears roughly the same in every direction. If this principle holds true, it means that the universe stretches on with no end, with no boundary. The second theory suggests that the universe is finite but doesn't have a clear edge either. This means it is similar to a large ball, and if you keep going in any direction, you'll eventually loop back to where you started. The third theory is the multiverse theory, which suggests that our universe is just one of many. Imagine a group of parallel universes, each with its own set of rules and properties. These universes could be completely independent from each other or somehow connected. So, we have talked about ideas surrounding the edge of the universe by looking at various theories. Now, Let's turn our attention to a superb tool that holds the potential to shed light on these mysteries. The James Webb Space Telescope, JWST. This amazing telescope allows us to look far back in time and discover unexpected objects from the early days of the cosmos. The JWST, with its advanced capabilities, has enabled astronomers to peer back into the early days of the universe and guess what they have stumbled upon. Something surprising. In a recent study published in the journal Nature, the JWST found 6 massive galaxies that existed between 500 million and 700 million years after the Big Bang. Researchers were only expecting to find small, newly formed galaxies, but the JWST caught them by surprise. These galaxies are way larger than anyone ever imagined, challenging what we thought we knew about the early cosmos. But that's not all. Scientists also found something mind-boggling. These galaxies are as mature as our 13-billion-year-old Milky Way galaxy. The mass of stars within each of these objects totals several billion times larger than that of our Sun. According to the research, one of them especially is probably as much as 100 billion times our Sun's mass. For comparison, the Milky Way contains a mass of stars equivalent to roughly 60 billion suns. You see, this telescope has a unique power. It can see things that are invisible to our eyes. By using infrared light, it picks up the faint glow from old stars and galaxies that have been around for a while. This means the JWST can actually take us back in time, providing a glimpse of what the universe looked like around 13.5 billion years ago. Now, here's where it gets really exciting. The universe is estimated to be around 13.7 billion years old, so this discovery has turned things upside down. It's like rewriting the history books. These enormous galaxies, nicknamed universe breakers, have scientists scratching their heads. They defy 99% of the models we had for early galaxies. We used to think galaxies started as small clouds of stars and dust, gradually growing over time. Well, these universe breakers proved us wrong. When the initial data and high-resolution images from the telescope became available in July 2022, researchers were blown away. They were shocked when they saw these galaxies as bright points of light, doubting their own interpretation of the data. The unexpected appearance of these giant objects, almost as if they wanted to be found, amazed everyone. By using spectroscopic techniques to analyze light across different wavelengths, scientists can uncover valuable information about these galaxies, including their composition, size, and distance from Earth. What's fascinating is that this groundbreaking discovery wasn't even at the top of the list of things scientists hoped to find with the James Webb Telescope. It surpassed all expectations and unfolded much faster than expected. There's even a possibility that some of the objects observed using JWST data could be something entirely different. While most are likely galaxies, there's a chance that some could be hidden supermassive black holes. Here's the exciting part. The known mass of stars within the universe is now believed to be up to 100 times more than we previously thought. This discovery remains mind-blowing, even though we consider only half of the sample. Meanwhile, using the powerful James Webb Space Telescope, JWST, an international team of astronomers also made a significant discovery. They found the oldest and farthest galaxies ever confirmed. These galaxies take us back to a time when the universe was just a fraction of its current age, fewer than 400 million years after the Big Bang. The light from these galaxies reached us more than 13.4 billion years ago, as detected by the telescope. Just like the early observations made by the Hubble Space Telescope, the initial images captured by the JWST revealed numerous potential galaxies. Now, through meticulous spectroscopic observations, astronomers have confirmed 4 of these objects, allowing them not only to study the physical properties of the galaxies, but also to accurately determine their distances. To determine a galaxy's distance, astronomers calculate its redshift. You might be wondering, what is redshift? Well, it turns out that as the universe expands, objects appear to move away from us, causing their light to stretch and shift toward longer, redder wavelengths, a phenomenon known as the Doppler effect. While redshift estimates can be derived from images taken through various filters, spectroscopy is the preferred method for obtaining precise measurements as it breaks down the object's light into its constituent wavelengths. The new discoveries focus on 4 galaxies with redshifts greater than 10, meaning they're incredibly far away. The Hubble Space Telescope previously spotted two of these galaxies, and their redshifts were confirmed to be 10.38 and 11.58. But the JWST images revealed two even more distant galaxies with redshifts of 13.20 and 12.63. Redshift 13.20 indicates a time period roughly 13.5 billion years ago, screening in ancient cosmic history. Moreover, the JWST's Advanced Deep Extragalactic Survey, JADES, is an ambitious program that has been allocated over a month of the telescope's time. Its objective is to provide an unprecedented in-depth glimpse into the early cosmos. In 2015, a consortium of research groups proposed this project, forming an international partnership known as JADES, comprising more than 80 astronomers and scientists from 10 different countries. Starting with the JADES program, it dedicated over 10 days of project time to observing a small area of the sky, including the Hubble Ultra-Deep Field. For over 2 decades, astronomers have been exploring this region using various large telescopes. By studying the field in 9 different infrared wavelength bands, the JADES team made a remarkable discovery. Almost 100,000 distant galaxies, each billions of light-years away. Following this, using the NIRCam spectrograph, the scientists collected light from 215 faint galaxies during a 3-day observing period. This enabled them to reveal the characteristics of the gas and stars within these galaxies and obtain precise redshift values. With these measurements, astronomers can determine the intrinsic brightness of the galaxies and estimate the number of stars they contain, allowing for a comprehensive examination of galaxy formation over time. Even without direct knowledge of their early growth stages, studying galaxies can be as challenging as understanding human beings. The early generations of stars have a profound impact on the fate of galaxies, similar to how our early experiences shape our lives. This is an extraordinary time in history when the transformative capabilities of the JWST are answering numerous questions about galaxies. NASA's Deep Space Observatory Telescope is revolutionizing our understanding of the cosmos and unveiling a treasure trove of new discoveries. The James Webb Space Telescope, a pioneer in scientific research, is providing us with remarkable insights into galaxies, planets, stars, and other fascinating cosmic phenomena. Launched in December 2021 and expected to operate for 2 decades, Webb is already embarking on its cosmic journey, surpassing the standards set by its predecessor, the Hubble Space Telescope. Webb has captured the imagination of scientists and the public alike, inspiring a wave of scientific enthusiasm. People worldwide are eagerly enhancing the telescope's raw data, sharing its breathtaking images, and gaining fresh perspectives. Following a remarkable deployment process, Webb astonished us with its initial images in mid-July, granting us an unprecedented view of our universe's myriad components. With the help of its advanced infrared telescope, we can explore the farthest galaxies in incredible detail and peer into the depths of the past. Within days of going online in late June 2022, Webb's powerful instrument began revealing thousands of previously unknown galaxies, older and more remote than ever imagined. Moreover, the telescope's capabilities allow scientists to collect ample light from celestial objects such as exoplanets and newborn stars, unveiling their compositions and tracing their trajectories through space. This wealth of information is already unveiling complex details about the atmospheric compositions of planets located hundreds of light-years away from Earth, hinting at their potential habitability. But not just that, by analyzing faint traces of light from the universe's infancy, the James Webb Space Telescope has potentially identified the oldest black hole ever found. This supermassive black hole, with a mass 9 million times that of the Sun, resides at the center of a young galaxy that formed 570 million years after the birth of the universe. Thanks to Webb's powerful cameras, capable of peering back in time to the cosmos's earliest moments, this groundbreaking discovery provides insights into the cosmic dawn when numerous black holes grew in size over the course of 1 billion years. From the Big Bang to the origins and proliferation of these enigmatic cosmic entities, mysteries that puzzle astronomers, some of these massive cosmic disruptions emit light observable by telescopes, created by the friction of material spiraling into their gravitational abyss. These objects, known as active galactic nuclei, AGN, supermassive black holes or quasars, are billions of times more massive than the Sun, radiating intense bursts of light trillions of times brighter than the brightest stars. As scientists venture deeper into the cosmos, they can capture light from more remote sources, providing glimpses into earlier stages of the universe. The James Webb Space Telescope, JWST, employs its mid-infrared tool and near-infrared camera to scan the sky, searching for black holes. Its built-in spectrographs then separate the light spectrum into different frequencies, allowing scientists to analyze the history embedded within the light. During their investigation, scientists made a crucial discovery. The heated material surrounding a black hole emitted faint lines of radiation across the universe. By scrutinizing these delicate glimmers from the universe's infancy, they detected an unexpected surge among the frequencies embedded in the light, offering valuable insights into the cosmic processes at play. The rapid appearance of black holes in our young cosmos remains a mystery. Scientists continue their search for much younger primordial black holes, believed to have formed right after the Big Bang or possibly even earlier. However, these elusive objects have yet to be found. Meanwhile, two main explanations exist for the abundance of black holes in the present universe. One possibility is that they are remnants of massive stars that formed much more rapidly than the stars we observe today. Alternatively, it is proposed that dense clouds of gas suddenly collapse to form these enigmatic singularities in spacetime. A more speculative scenario involves population 3 stars, a hypothetical class of stars that emerged approximately 200 million years after the Big Bang. Primarily composed of hydrogen and helium, these stars were likely much more massive than those formed later, leading to the formation of supermassive black holes. In 2017, the Sphere Consortium made a significant discovery by identifying a planet called HIP 65426b using the spectropolarimetric high-contrast exoplanet research Sphere instrument. HIP 65426b is an exoplanet that orbits its host star, HIP 65426. In September 2022, it gained further attention as the first exoplanet to be directly observed by the James Webb Space Telescope. What makes this planet particularly interesting is its unique characteristics combined with the JWST's exceptional sensitivity, allowing for easier observation. Unlike any other planet in our solar system, HIP 65426b is situated at a distance from its host star that is 100 times greater than the distance between our Sun and Earth. To give you some perspective, Pluto is just 40 times farther from the Sun than Earth. Now, imagine an exoplanet that's a large gas giant about 12 times the size of Jupiter, orbiting its host star at an astonishingly close distance, roughly 8 times closer than Mercury is to the Sun. Finally, Webb was designed to project to the farthest reaches of the universe, and researchers have confirmed its success in doing so. Webb was designed to peer into the farthest reaches of the universe, and researchers have confirmed its success in doing so. This achievement marks a significant milestone in our quest to understand distant planetary systems and the cosmos. The James Webb Space Telescope's observations of exoplanets like HIP 65426b provide valuable insights into their atmospheres, compositions, and environmental conditions. By analyzing the light that passes through or reflects off these distant worlds, scientists can infer the presence of specific gases, such as water vapor, methane, and carbon dioxide, which are crucial for understanding their potential habitability. The discovery of HIP 65426b by Webb underscores the telescope's ability to detect and study distant exoplanets with unprecedented precision. This capability opens new avenues for exploring the diversity of planetary systems beyond our own and advancing our understanding of planetary formation and evolution. In addition to exoplanet research, the James Webb Space Telescope is poised to revolutionize our understanding of other cosmic phenomena, including the formation of stars and galaxies, the evolution of the early universe, and the nature of dark matter and dark energy.